Alright, let's get going on this. This is homework number 3 for chapter 2. Number 30. When Yoshi grabbed the line y equals 2x plus 3 and y equals 2x minus 2, she got the graphs at the right. These two are here. Okay. One of the lines at right matches the equation y equals 2x plus 3, and the other matches the equation y equals 2x minus 2. Which line matches which equation? So, because they're, if you notice that they're both 2x, which means that they both have a slope of up to and over 1. So therefore, the only thing we really need to look at is where it crosses the y-axis, or this line right here. Right. So if you look at this, the first one right here, y equals 2x plus 3 has a plus 3. Right. So therefore, you're going to have to figure out that this is going to show up at the 1, 2, 3 right here, which is the blue one. So this line right here, y equals 2x plus 3, is the blue one, and y equals 2x minus 2, there's no minus 2 in the back right here, that minus 2 right there, that's going to be minus 1, minus 2 right here. Okay. So if you want to say something about it, okay, so I'll say something like y equals 2x plus 3 is the left graph or left line, and y equals 2x minus 2 is the right line. Yoshi wants to add the line y equals 2x. Okay, same thing, 2x again, so it's going to look just as like these two here. 2x plus 1 to her graph. Predict where it would lie and sketch your graph to show its position. Justify your prediction. Right, so I'm predicting it's going to look the same, except it's going to sit right at positive 1. So if I'm going to graph it, it's going to end up, and I'll put that one in green, y equals 2x plus 1. So it's going to start at positive 1, and it's going to be up to and over 1. So yep, it's going to sit right in between. Okay. So I'm going to say something like y equals 2x plus 1 lies between y equals 2x minus 2 and y equals 2x plus 3. Alright, part C. Where will the line y equals negative 2x plus 1 lie? Again, justify your prediction and add the graph to of the line for your graph for part B. Right, so I'm going to predict, I'll put that one in purple, but this one's going to start at 1, so same place as the green right there, but it is going to be down 2 and over 1, so it's going to look like it's going the opposite way. So down 2 over 1 would be right here. Okay, and if I keep doing that, down 2 over 1, down 2 over 1, from here down 2 over 1, and down 2 over 1. So this line will be going exactly opposite of what the other lines are. So I'm going to say something like y equals negative 2x plus 1 is, well, let's say it starts or has a y intercept of 1 but goes down 2 and right 1. Okay. Okay. find the slope between the 2 points. Okay, we're going to use Gloria's method on this right here. Gloria's method. Basically, you pick which side you want to start on. Right. So I'm going to say, well, I want to start in the front because the front numbers look bigger, right? And it doesn't matter. It may very well end up being different or not. Okay, you just make a decision and go with it. So I'm going to go ahead and write down that my slope is equal to, and I'm going to start with -3. Remember, you start with the y first because slope is the change in y over change in x. So you're going to start with the y first. So, -3 minus -1. So you can write like that. And notice how I said it, -3 minus -1. And you're also going to do 6 for the change in x minus 2. Okay, and that's going to get you -3 plus 1, because the double negative makes positive. And then 6 minus 2 is 4. So -3 plus 1 is going to be -2. And then the bottom is just 4. And -2 over 4, that comes out to be -1/2. Okay, you can leave it like this, or you can change it to a decimal as -0.5. That's fine as well. Okay, this one here, I'm going to start with m equals, okay, so then again, it's the change in y over the change in x. Okay, I'm going to just utilize that one right there. So change in y, and let's say this time we're going to start in the back. So -8 take away -18. So you write like that, -8 take away -18. And then we're going to go -58, sorry, not negative, 58 minus 73. Okay, and that's going to be, let's see, -8 minus a -18, the double negatives right here. Those make plus, those make it a positive, so it'll actually be -8 plus 18 over, and then 58 minus 73. So if I went the other way, it would have been positive, but 58 minus 73 would end up being -15. And it's okay, you just live with what you decide. Okay, -8 plus 18, that's going to give me a positive 10 over -15. Okay, I can divide each of them by 5. And that's going to give me 10 divided by 5 is 2. 15 divided by 5 is 3. And then since it's positive divided by negative right here, it's going to end up being a negative answer. So you can just say that your answer is just going to end up being a -2 over 3. And that's fine if you like fractions. Or you can call it -0.666 repeating. So you can just write like that. Okay, so this looks like it's a little bit further back. This looks like simplifying exponents. Right, so you notice that this is a division or fraction, so I'm going to first reduce or divide that. So 5 over 15, or if you divide both of them by 5, you will end up with a 3 on the bottom. Okay, you look at the next part, x to the second divided by x to the fourth. Okay, that's going to be, if you subtract, you get x to the -2, which means it actually belongs in the bottom. So you have x to the positive 2 on the bottom. Okay, you can think of this as x times x over x times x times x times x. And see what happens? X on top cancels with x on the bottom. X on top cancels with x on the bottom, and you have 2x squared on the bottom, just like that. And then you have at y to the 9th and y to the 9th. Oh, that just cancels out, right? So your answer should just be 3x squared on the bottom. And since you don't have anything on top, you need to put something on top to kind of hold it place. So you have 1 over 3x squared, which is on the bottom. All right, that's your answer. Okay, next one. This one's not a fraction, so you cannot be dividing them. but you are going to use the exponent or the power properties for exponent, right? So basically, there's two of these. So if I rewrite this, it's going to end up being 3x y, right? And there's two of those because that 2 right there, just like this 2 represents y. So that 2 right there represents there's two of these, 3x y, and then we also have the 2x y from this part right here. Okay, so what do we have? Well, we have 3, 3, and 2, so I'm going to write it as 2 times 3 times 3. If you want to write it all together and multiply it out, you can. Okay, we'll talk about that in a bit. And then let's count how many x's. So we got 1, 2, 3. So that'll be times x to the third. And let's count how many y's. 1, 2, 3, 4, 5. So this will be times y to the fifth power. This is fine, but if you want to multiply the 2 times 3 times 3, which is 6 times 3, you will get the answer of 18 x to the third y to the fifth power. All right. Let's look at the last page. Which graph below has a domain of all real numbers, which have a range of all real numbers? Which are functions, right? So all real numbers, that means that it goes as far left and right and as far up and down. So see this arrow keep going down, which means it's going to keep going to the left side. And see this arrow that keeps going up, which means it's going to keep going to the right side. So our domain is going to be all the way to the left and all the way to the right. So this one's going to be all real numbers. Domain is going to be all real numbers. So let's see if this is true. This one has a little arrow going kind of diagonally down, which means it does keep going to the left. And this one also has a arrow going diagonally down, which means it's also going to the right. So this one, the domain is also all real numbers. Okay. This one, you can see it. It's pointing to the up and right, and then it's also pointing down and right. So that means it's only going to the right. Okay, so as far left as it goes, it stops right there at -2. So the domain on this one is, it's going to be from -2 to x and less than infinity. So this one's not all real numbers. So this one does not work. Okay. Second part, which has a range of all real numbers. Okay. Since we're talking about range, talking about down and up, right? So again, looking at the arrow, right? So this first one, arrow is pointing diagonally down and to the left, so which means that it is going down. So that means that it is starting at -infinity, and this one has an arrow kind of pointing up and to the right, which means it is going up. So this one has a range of all real numbers. Remember, all real numbers just means that it's between -infinity and infinity. So that's how we write it sometimes. Okay, well that's how we usually write it. But you can also say it's all real numbers, which means it's everything you can think of. Okay. This one has a arrow pointing diagonally down and to the left, and this one has an arrow pointing diagonally down and to the right. Okay, so that means that it goes all the way down. So the range goes all the way down to -infinity, but it doesn't go up, right? It just goes all the way down. Okay, and the highest it goes is just right here, so it doesn't go all the way up. So your range is going to be from -infinity less than y less than, and then it only goes up to 2, let's say 4, 5, 6. Right, so that means that's not all real numbers. So this one does not work. Okay. Let's do the last one. Last one has an arrow pointing to the right and up, which means that it is going up. And this also has an arrow going to the right and down though, so that means that it's going all the way down. So this does have all the range. So basically the range on this one goes all the way from negative infinity to infinity, which is all real numbers. So this one does work. Okay. So each one has its own domain with all real numbers. The first one has both domain and range all real numbers. The second, letter B, only has a domain of all real numbers, and C has only the range of all real numbers. Okay. Which one are functions? Well, you got to do a vertical line test to see which one's it's actually a function. So vertical line test basically means you need a vertical line, and you need to bring it across. So this one touches it one time each, right? So for example, this one touches it right here only. If I move it over here, touches it right here. I move it a little more over here, touches it right here only. So this one is a function. I'll use purple. I'll say function. This one, I bring it here, only touches it once right there. I bring it over here some more, touches it a little bit right there only. Right here, touches right there only. Right here, touches right there only. Over here, touches right there only. So this one is also a function. Okay, last one, I take this vertical line, I bring it right here, oh, it touches it once, and it touches it twice. There's two places where it touches. In fact, the only place that it will only touch once is if it barely touches it right here. That's when it only has one time. Right there, only touches it once. Okay? But anywhere else, all the way over here, once, twice. All the way over here, as it gets bigger, it's going to be once, twice. Right here, once, twice. Okay? Right here, once, twice. So this one is not a function. All right, we'll call it a wrap.